Hi all, and welcome to another Generative Components tutorial. Today we'll be looking at turning two-dimensional text showing site levels into a 3D mesh. So let's get started. For this exercise, I've referenced in a typical site survey. As you can see, if we rotate into a front view, all the level information is on the XY plane or on 0, 0. I've turned off the site information, leaving only the spot level text and some annotations. This has left us with some lines, some numbers, and text all on the same level. So switching back to the computational design workflow, my first step is always to click on the point tool to generate a base CS by clicking yes and OK. With the point tool active, let's place a point to the top left of the site information and one to the bottom right. This will be the limits of our range box. To ensure we pick up all the text, I'll just change the Z value for point 1 to 50 and negative 50 for point 2. Next, let's drag in a range node and connect point 1 to the low point and point 2 to the high point. Dragging in a text node and changing its method to from elements in range, we can simply link this up to the range node. Now you can see we have extracted the text from the reference file. It does, however, contain both numbers and text in text format, so we'll need to perform some checks later on to see if the text can be converted to numbers or not. For this, let's drag in a point node and change its method to by function. And let's click on the square to access the text editor and start writing our function. In this function, we're going to take text values and create points at the required relative levels. So starting with the word function, we'll open brackets to list our inputs. The first will be the text input, and I will call it input text. And for the second, I'll set up a double and I will call it RL limit. I'll use this to remove some levels that are not site levels, like ridge lines, gutter, or chimney levels. We close the brackets, and then we open and close curly brackets to contain our function. And now I can start our function. My approach is to always list my output as the first line of my function. In this case, it'll be a point called myPointList and equal that to an empty container with an open and closed brackets followed by a semicolon. Then I'll start a loop to run through the input text. Typing 4 and tapping the tab key a couple of times will auto fill out the line string. And here I just change the count to inputText.count. with a capital C. Inside this loop, we'll convert the text to doubles and then create some points from this information. The text, however, is a mixture of letters and numbers, and the letters will not successfully convert to numbers. So let's do a test first. So let's set up our variable. It'll be a double, and I'm going to call that myTestDouble, and I'll equal that to our empty container with the open and closed curly brackets followed by the semicolon. So with the next line, let's start a check with the if statement. So we type if and then open brackets, and then inside double dot try pass and then open brackets input text in square brackets I dot text string. This will be the text string we want to test, and then we put in a comma and we type out, and then we type my test double, close brackets, and then close brackets again. This statement will do a bool check if the input text item we're looking at will successfully pass or convert into a double. If it is successful, we can then use it to generate a point. So we can open and close the curly brackets for the if statement, and let's indent this statement so it's a bit easier to read. Now we have checked the text will convert into a double. Let's do that in the next line. So we set up a double called myRL equals to double with open brackets, input text brackets I dot text string, close brackets, and then a semicolon. Now we can use the myRL to create a point. However, in this file, it is in millimeters, and the RLs are listed in meters. So first we'll have to run a quick conversion. And for the next line, we'll type in myRL equals myRL times 1000. Now we're set up to create a point at the right RL. However, I'd like to create a point at the center of the text, and there's no center point for this text. There are a couple of ways to achieve this, but here I'll show one that takes some high and low points of the text and draws a temporary line between those points and then finds its midpoint. Then we can create a point at the required RL as an offset of this point. There are other methods like point by centroid of set that might be more efficient, but for this exercise, let's use the line method and see how it works. So the next line, we'll create a point by starting with the word point, my low, which will be the low point, equals new space point, open and close brackets, dot by Cartesian coordinates, open brackets, the base CS, which will be our coordinate system, comma, input text, square brackets I, dot drange 3D, dot low, dot x, comma. And then we can copy this input text string that we just made and use it as the same string, but then change the values to y and z. Then we can close brackets and place a semicolon. We can repeat this for the high point, calling it my high. Then we can create the temporary line called myCrossLine, and we do this by equals new line, open and close brackets, dot by points, and then open brackets, and enter my low, comma, my high, and then close brackets and a semicolon. To create the center point, we start with the word point, and I call it my center point, and the equals new point, open and close brackets, dot, and we're going to use by parameter along curve, and then we open brackets, and we use my cross line as the input line, comma, and 0.5 as the parameter, which will place a point at the midpoint along the line. Then we can close the brackets and place a semicolon. Now we can create that final point. So we start the line with point, and we'll call it my RL point equals new point, open and close brackets, dot, by direction and distance from origin, and then we'll open the brackets, and for this the origin is going to be my center point, and then comma, direction will be the base CS dot Z direction, and for the distance we can use my RL. Then we can close the brackets and place a semicolon. Now for the last line in this part, all we need to do is add this point to our point list. So it's myPointList.add, and we can copy my RL point, and we can open brackets and paste in my RL point, and close brackets and a semicolon. Now we can just type return myPointList semicolon just before the last curly brackets to return the points at the end of the function. And if we click apply, you can now see the inputs are now on the point node. This, however, does not use the RL limit that we set up to remove those rogue points we don't need. So for this example, let's put in 66 into the RL limit and link up text1 to the input text. And you can see if we rotate the view, we have a series of points for the site. However, there are a few rogue points that indicate the gutter and ridge line that we don't want as part of our site model. And if we look at the low and high points of the site, you can see down at one end, they range from about 62.2 up to a high point of about 65.6. So opening up the editor again, we can indent the main body of the function and insert an if statement before it. For this, if we start with an if and then open brackets, and all we need is my RL is less than RL limit, and then close brackets. Then we can insert the open curly brackets before the body and a closed curly brackets after the body section. This will then check to see if the RL is under the RL limit, and if it isn't, it just won't process this loop and continue on. So if we click apply, it will generate the RL points again, and this time the rogue points have been removed. If we change the RL limit value again to say 80, you can see the high points are included again. Similar, if we go down to 64, we can trim off values. So let's change it back to 66, that will include all the points we need. So next, let's drag in a mesh node and link it up to point 3. Finally, we could drag in a B-spline surface and change its method to from mesh and link it up to mesh 1. And if we right click on the mesh, we can turn off its visibility. Changing the view to illustration with shadows, you can now see we have a site surface automatically created from a reference file of 2D text RL values. We can now replace the reference file, and if needed, it's an easy adjustment of the range box to suit the new site, and a new surface will be automatically generated. Hopefully you'll find a way to incorporate this concept into your next project. Until next time, thanks for watching.